Doing good. All right. All right. Well, thank you all for attending this talk. Really appreciate it. We're going to talk about a subject I'm very passionate about because, just like many of you, I'm sure I've been thrust into less than fun situations when dealing with legacy software, and the same question comes up over and over. I wish I had done it better. And what could that better look like, right? And so there's a lot of wisdom out there, and all I'm going to do is present a lot of this existing wisdom, but in a way that has worked really well for my teams and I. Especially in the last 3 years, it's been very impactful for us. So I figure I'd kind of share this stuff. So the talk is a journey toward clean code and enjoyment. This is me. So feel free to say hi on Twitter, LinkedIn. And so today we're going to try to answer 3 questions. What makes software not fun? Where does it hurt us? And what can we do to make it fun? So the punchline of this presentation is going to be that test-driven development is going to be a big help toward making software fun again. But you kind of have to build toward it because we've all looked at TDD tutorials and they help you kind of solve small algorithmic problems, but when you're working with web applications, it's a little bit harder to figure out where to start. And proper architectures are going to facilitate this process. We're going to cover that ahead of that. But before that, object-oriented programming is going to emerge as an enabling concept toward achieving those architectures. So we're going to look at ways to really embrace that. And then ahead of that, we're going to look at a broader sense, kind of what makes better code. OOP is going to emerge as one of those factors that helps make better code, but we're going to look at several other things as well. And then ahead of that, what we're going to do right now is jump into kind of the impact on bad code on your agility, because you hear a lot, everybody's agile these days, right? What does that mean? So let's dive into that. Sure, many of you are familiar with Robert C. Martin, Uncle Bob, right? So he famously said, "It will be a long time before I trust software to drive a car I'm in, because I know." Obviously, he knows how bad software can be. As you know, software drives just about every aspect of our lives. If Tesla has its way, it's going to drive all of our cars really soon instead of us. Of course, you might ask yourself, what could possibly go wrong? I don't know, maybe this. That's a Tesla at a Tesla dealership. Irony much, right? So, let's look at code versus fun of coding. What's not fun usually is inheriting somebody else's code. Right? You look at the code, you're like, what is this doing? I have no idea. Then, you're trying to build new things on top of this legacy code, and when you do that, you're going to break a bunch of other things. That happens a lot. And of course, you want to avoid breaking things, and to avoid breaking things, you got to be testing things, right? You got to click throughout the application, making sure that it still works after having made all those modifications. And of course, we don't like doing that, so we don't do it as much as we should. So these are a lot of the pain points that I've come across. I'm sure it's very familiar to you guys. And I like to look also at the impact of bad code on your agility. You hear a lot about agility. At some point, every software company is going, we need to be more agile. And the Agile Manifesto pretty much got completely ignored. It got taken over by project managers, and this is what happened. We spent a lot of time reinvented project management and task planning, so Scrum and Kanban came away. Great, we're agile because we have Scrum and Kanban, awesome. Then we looked at integration, right? Kind of pushing your code from one environment to the other all the way to production and dealing with the challenges of integration, right? So we built systems to do continuous integration and continuous delivery. So that's cool. You have that, and you think you're agile as well. And then, of course, there are a lot of frameworks out there. Every web framework out there is agile, and it's rapid development. It will solve all your problems. So we have those. So by and large, pretty much, most companies out there, if you ask them, are you agile? They're going to say, yes, I am agile because one or all 3 of those things, right? The problem is there's a big underlying issue that looms under all that, and it's really bad software, right? So if you're writing bad code, it doesn't matter that you have planned a 2-week scrum. Guess what? It's going to take 4 to 6 weeks to get that sprint done. It's going to turn into a really long marathon before you know it. That's what happens when you deal with technical debt. Your continuous integration system, you're going to be automatically merging a lot of code that has all kinds of conflicts and breaks all over the place because you have big monolithic classes and then you have 5 engineers working on those classes at the same time, and they're all conflicting with each other's code. You're going to dramatically undermine the effectiveness of that. In your MVC framework, it's really not going to bail you out of your bad code, right? So Martin Fowler has a great article on all this. I highly recommend that. On this presentation, I have a lot of links to people much sharper than me. So the PDFs will be available. Click on those links and read those articles and watch those videos. So by and large, most companies think they are agile, but they're not, because bad software eviscerates just about every benefit of the agile stack. So what's the impact of this? Now, if you look at a graph of new features released over time, before I show you that curve, the first thing that we're going to do is accumulate a lot of technical debt at an astronomical pace. And then when that happens, well, this happens. You start on your project, it's greenfield, you're able to release a lot of new features really fast, you feel really good, but then you're writing a lot of really bad code really, really fast. It starts weighing you down to a point where you get pretty quickly to a point where it takes you a near infinite amount of time to get nothing done. When you get at the bottom of that curve, life is the opposite of fun.
Get a new job.
Huh?
Get a new job.
Right, well, that's usually what happens, right? Like software engineers will,
Somebody else do it.
we'll stay out of a job for 1 year, put a bunch of technical debt, and then move on. That's the way to go. So obviously it has an impact on your business value, right? Kind of this straw shape. Start out great, then you plateau, and then you can't pivot. Your competition is sitting on the sidelines, looking at you, looking at your successes, your failures. They're going to start from scratch because they don't have the weight of that technical debt, and you're going to put them in a position to drink your milkshake. And it's not a place you ever want to be. So, again, Uncle Bob talks on a lot of these topics as well, so I highly recommend this talk. I like to make convenient bit.lys. So, we looked at the impact of bad code on agility. Now you might ask, okay, well, what could be better code, right? So, when it comes to better code, I like to look at enablers. And I like to look at 3 components: test-driven development, clean code, and patterns. Now, you could argue that all of these 3 should all fit under clean code. That would be perfectly reasonable. I like to kind of separate things out, so it kind of helps focus the learning process, the coaching process. So I like to look at these things as enabling factors for better code, for writing better software. So let's start with TDD. We're actually going to build up toward TDD toward the end of the presentation. That's kind of what we're trying to build toward, right? But then there's also clean code. So for clean code, we could do a whole talk on that, but instead, I'm going to refer you to Robert C. Martin's book right here, the Clean Code book. It's one of the more impactful books I've read and used every day. It'll show you how to write code that is self-documenting, easier to maintain. It'll call out a number of code smells that you should look out for among your teams. Overall, it'll really show you with concrete examples how to build a lot more maintainable systems. This is Tom. We work together. So, TDD, we're going to build toward that. Clean code we just covered with the book. And now let's look at patterns. So, before jumping into patterns, you're all pretty familiar with programming paradigms out there, right? pretty much every software language is able to support one or more of these paradigms. So you got object-oriented programming, that's well known. You got procedural and imperative. Procedural means you'll be able to stash functionality and functions. Imperative means you'll be able to define variables, change the values of those variables, and it means you're going to be able to have systems that have state in them. Functional would kind of be the opposite of this, sort of, because a functional programming environment really forces you to, you almost never define any variables in there, and it forces you to define functionality that is completely encapsulated in a single function. So we're going to touch a little bit on that a little bit later. So these paradigms are nice, but on their own, they are of limited use. What we got to do is seek out and leverage patterns that play to the strengths of those paradigms. So, because the goal of these patterns, in the end, the goal of any pattern is to simplify the complexity of a system. Right? So if you look at these programming paradigms on the left and some of the principles and patterns that have emerged over the years, you could say that these principles and patterns have definitely been at their inception slanted toward object-oriented programming. With this said, they're pretty much all adaptable in some form or fashion to functional programming. With this said, the rest of this talk is definitely going to focus on OOP and OOP design patterns. But I wanted to also call out that there are a lot of the same things you can do with functional programming as well. It really depends what kind of environment you're in. Again, the idea is to understand what you're working with and to play to the strengths of what it is you're working with. So here I have a link to this really helpful design patterns URL. You have examples of design patterns in PHP, and they're also explained, right? So it's very useful. And then if you're interested in functional programming, I have a bunch of links on functional programming talks that I highly recommend. It'll show you some of the patterns, some of the use cases behind functional programming, a lot of really good learning to be done there. I'd like to call out Anjana Vakil's Intro to Functional Programming, really great talk. It goes over persistent data structures, which I think are really interesting. So yeah. All right, so now back to OOP. With Tom and the rest of the team, we looked at some of the design patterns, the OOP design patterns that we come across almost every day in our project, ranked 0 to 3, 0 being the most often used, the 3 still used pretty often. So these are the ones that we come up with all the time. I'd be curious to see after this talk if you guys want to tell me some of the design patterns you work with on your projects, kind of what has helped you out. It'd be interesting to see. All right, so this concludes this section on enablers of better code. We're going to look at TDD toward the end. That's Uncle Bob's book, and we just look at patterns. Cool? So now we just talked about OOP. Using OOP design patterns with OOP. I kind of want to drill down a little bit on that because often what I see out there is what I call flaccid OOP. You got a project where a lot of OOP constructs are being used, classes and abstract classes and classes extending one another to really deep level when the bottom class has nothing to do with the parent class, but hey, they're still extending one another, right? And it kind of smells like this. You have a large system, you start building a couple components in OOP, and there are a lot of tight couplings already between those components. Then you add more components, and then you couple them all up together, and then you pile up a lot more components on that, and it's all tightly coupled, right? Well, what happens there is, with those tight couplings, if you change any part of this system, you could break everything else, or you could break any number of other things. That's not what OOP wants you to do. With this said, a lot of this is being done. And the reason why this happens is because there is, developers will do an indiscriminate use of OOP constructs. I'll just instantiate this class here, and I'll just instantiate this class here, and you have a lot of tight couplings, no dependency injection being used, And you end up with a system with very unpredictable couplings. You can look at any class and it's going to be really hard to predict what the state of the system should be by the time this class is being used. And there's going to be a lot of violations of the law of Demeter. I have a link there as well. Every time you see an underline, it's a link to look up more things. So in the end, if you're working with OOP, the goal should be, and these should be the goals of any system, right? But you want to arrive at a simple, maintainable system. And a way to arrive at that is to have loosely coupled components and with a consistent dependency graph. And to achieve all that, you're probably going to embrace design patterns. So in the end, your large system ends up looking more like this. So with loose couplings, you can change one thing and break nothing. Design patterns. So, all right, this was a bit on OOP. Now we're going to look at web application architectures. So we have a reasonable understanding of kind of good and bad ways of doing OOP and kind of what design patterns can do for us. When you're trying to build a web application architecture that is conducive to building complex systems or conducive to test-driven development, there are some architectures that may work better than others. And so we're going to try to identify some challenges and some ways to solve those challenges. So I'm sure everybody here has worked with MVC, right? Model View Controller. And it's been around for a long time. If you look at Uncle Bob's talk on the clean architectures, he traced it all the way back to the 60s, I think. It was designed for a system that had nothing to do with the way MVC is being used today. He's got an interesting take on MVC, so I highly recommend that talk. I'll link to that a little bit later. But by and large, we've made MVC work, right? It works really well if you're doing a little more than skinning your database, right? Where you have every URI of your application is doing one of the CRUD operations against your data store. And that works pretty well, right? And the thing is, most applications start out simple, but then do get more complex. And then you start having a lot of business logic, right? And then you ask yourself, well, where should I put all this business logic? You know, should it be in the controllers? No, come on, it's tied to the URI. Okay, well, let's put it all in the model. Okay, why do you want to put everything in the model, right? I mean, business logic could, and why not, should have, you know, its own layers, basically. So that's one set of limitations. It's like, you know, you tend to miss a layer for business logic. But another challenge I've come across is that in most frameworks, you end up writing your business in a way that it's coupled to the framework's middleware upstream, and it's coupled to the framework's data engine downstream. You know, why should you only have controllers and models, and why should you always be extending your framework's base model to get anything done? In the end, you're going to have a lot more fun doing test-driven development, and in the end, you'll have a more robust system if you're able to keep your business somewhat insulated from these things. It doesn't mean you're not going to use your framework. You're still going to use your framework, but you're going to do it in a way that it's more decoupled. And we're going to see a little bit more what that means. But think about this, and now think about an architecture where you could have more layers, right? So this blue circle that I showed here, imagine if all this business now was described in this layer. So this is an architecture that's worked really well for us. You got commands, services, and repositories. Each one of these things is a design pattern. It's one of the enterprise design patterns. In the link that I gave earlier, you can look them up, and it's pretty straightforward. But at a high level, you could see your services as the high-level capabilities of your business, right? Think of it as your API. Your service classes are roughly going to be your API. The commands upstream of the services, the commands are going to be very specific use cases. So it's going to be so in a system, you're likely going to end up with maybe a dozen service classes, but you might end up with many dozens of command classes, maybe hundreds of command classes. It really depends kind of the size of your system. But the thing here is like, you're not afraid to create a class to do one thing, one simple thing, and to use services to do that. So now your business logic is going to be spread across services and commands. Repositories are there to be your data layer. And so they're going to interact with your data store. It could be an ORM. It could be straight up PDO. Raw SQL statements. You could write a repository to do that. It could be a NoSQL store. In fact, with the repository pattern, you're putting your architecture in a position to do what Martin Fowler coined, I think, in 2012 as polyglot persistence. I have a link to an article that kind of talks about that. But basically, your application may start out with just using an ORM, or it may just be doing straight SQL to a database. But then one of your data types, maybe it's an application event type of data where that has kind of an infinite growth, and it butts up against some limitations of a traditional database. And you may want to transfer that part of your data storage to a NoSQL solution. That's perfectly fine. If you're using the repository pattern, and if things are decoupled enough, it is not a big deal for you to swap out implementations on your data storage inside your application. And your application could eventually be talking to multiple types of data stores and storing paradigms. It's not a big deal. One of the big things I like to do is extract interfaces between my architectural layers, especially between services and repositories. Because if today you have a repository that's backed by the Doctrine ORM, tomorrow you could have another repository that implements the same interface, but backed against object document mapper, like a NoSQL solution, right? And you would be coding against the same interface with a different repository implementation, so you would have zero impact on the upstream of your architecture. So it gives you a lot of flexibilities. So this entire green zone right here, this is what I will do 100% test-driven development in there. Okay, and so that code is going to be 100% covered at all times. Because it's going to be easy to do because this green zone is not coupled to my framework. So I'm just dealing with OOP, and it's really easy to do. Now, the yellow zone up here, that's going to be tied to your framework, the framework controllers, the HTTP transport, things like that. I like to keep my controllers really, really thin. I won't even put an if statement inside of a controller. All my controller should do is get some data from the request, extract some primitives and some objects, and pass them straight up to commands. Yeah, like I said, this architecture has worked really well for us, and we will see that this architecture will help us a lot when doing test-driven development. So this is what I just kind of talked about. All right. So if you're interested in learning more about this, recommend this video and this article. All right, so this was web applications architectures. Now we're going to look at how we can leverage this better architecture to do test-driven development. And I like to position test-driven development as actually the fastest way you can actually build anything. And it sounds a bit heretic and kind of crazy, I get it. But if you bear with me for a little, we're going to try and demonstrate that I kind of arrive there. So, like I mentioned, speed is one big reason why I want to do TDD. But before we demonstrate that, there's a more obvious reason that we want to be able to embrace change with any system that we're building. Requirements are going to change. We're going to want to have new features. And as we do this, we're going to want to constantly improve the code, right? You got a lot of technical, you want to make the code more readable if you're going to build new things on top of it. And constantly improving the code is really part of the DNA of test-driven development. Because if you look back at this graph, right, where to write better software, you want to try and do all these 3 things at once. Well, if you just start out by focusing on test-driven development, what you first build may not have the ideal patterns in there. It may not be the cleanest code you've ever written, but you will have written it in a test-driven way, so it will be 100% covered. So it means that if you start out compromising on these 2 aspects, over time, it's really not a big deal to constantly improve your code and finally arrive at better patterns and cleaner code. So I like to clearly call out what test-driven development is not, because you hear unit tests and you hear test-driven development. The unit test mentality is, I've written a bunch of code, I've tested that my code works in my web browser, and it's gone to QA and it's in production. Okay, now my boss wants me to have 100% unit test coverage. So great, now I have the daunting task of adding a bunch of unit tests to a bunch of existing code. Who wants to do that? It's not fun. Now with test-driven development, it's completely different, because you're never writing any code unless you have a test first that says what it is you're about to build. So it's just kind of effortless. Yeah. So I want to call out kind of the big difference between those 2 concepts. So, but like I mentioned earlier, there are challenges when doing test-driven development inside of web applications. When you look up TDD kata or TDD tutorial on YouTube, there are a lot of really good videos, and I highly recommend them because at least they kind of help you get a feel for what it should feel like. But they only show you how to solve kind of small algorithmic problems. Okay, great. I can do FizzBuzz in TDD. Awesome. I can do a bowling game in TDD. Awesome. How does that help me on my day-to-day job, right? Most of us here, we do web applications, and so we kind of want to make this easy on ourselves. So. And that's the thing about web applications. They have different architectural layers. They have many classes. They deal a lot with data, right? So you want to be able to wield these things inside of your test harness. So if I was to sum up goals for test-driven development in a web application, I would say I want to get the satisfaction of building business capabilities without leaving the soothing comfort of my test harness. I don't have to go into my web browser. I don't have to go into my database to see if whatever I just did worked. I'm inside my test harness, and I'm just cranking out code and having a lot of fun doing it. So that's something I'm very, very interested in. Poor Martin Landau, he passed away a couple months ago. Yeah. So anyway, without test-driven development, I like to look at where do we waste time today. I'm saying that TDD is the fastest way you can ever do things. Okay, well, we're probably wasting time doing some things today, right? And we are. We waste time while building things, and we waste time while testing things. If you think about it, you start out on a new project. What's the first thing you're going to do? You're going to install your web framework, right? Then you're probably going to go into your SQL Pro or your MySQL command line, and you're probably going to think through what it is that you're trying to build, and you're probably going to build at least a skeletal schema to represent the different tables that are going to make up the universe of what it is that you're going to try to build, right? So you're going to spend a bunch of time in SQL land to set up your local database. Then you're going to want to interact with that thing you're building. So you might use some scaffolding script to build a basic UI to interact with your code, or you may have to build it yourself. If you're doing Angular or whatever, you may have to kind of build it out yourself. Then yeah, sure, you're going to write code for your business logic. Okay, that's cool. Then as you build things, you're going to get unexpected behavior, so you're probably going to use a debugger like Xdebug to step through the code. If you're not doing that, you might use logging. Throw a bunch of log statements throughout your code so you can trace the behavior there, right? And what? var dump for the win. Yeah, exactly. So that's while building things. And then, while testing things, now that you've built all these things, right? You've built the state-based tax logic on your shopping cart application. What are you going to do to test that? Where are you going to log into your application? You're going to log as a user, maybe create a new user, create a new shopping basket for that user, add more items into the shopping basket, right? Finally get to the checkout, and then hopefully it works. No, it didn't work. Okay, start over again, right? So you're going to do a lot of clicking around the UI to verify that things worked. You're probably going to look at your database records, to see if the data changed the way you're expecting it to change. If you want to, maybe you might modify your database records manually so that you don't, to jump the application into a given state to verify behavior. And then while you do all these things, you're probably going to realize that you broke a bunch of things, and then you're going to have to start over and add more debug statements and all that stuff, right? If you add it all up together, it adds up to a whole lot of not fun, right? And what I like to call out is all these activities that I marked in red in these last two slides. You could consider them as throwaway activities. They're both manual and repetitive, and they're only relevant at that one time that you did it. In the end, I don't want to do any of that stuff. I always want to be coding. So, with TDD, you're not doing any of that silly stuff. All you're ever doing is you're thinking of something that you want to build. Okay, you're going to write a failing test to describe what it is that you're going to build. Then you're going to write just enough code to make that test pass. And then you're going to ask yourself, should I refactor? Maybe, maybe not. And that's all you're going to do. And then you just click to run your tests, and that's it. That's all you're ever doing. And these activities that I just marked in green, they're foundational because they're permanently relevant, because your tests get run all the time. So that's nice and all, but in the end, you want to be able to work effectively across those architectural boundaries. You want to be able to introduce meaningful data into your unit tests as you're doing test-driven development, and you want to be writing meaningful assertions. So how are you going to achieve that? So here's what we've been doing, and that's been working really well for us. We've worked with any kind of XUnit test harness. So every day we work with PHP unit. That works really well, but you can do it with any unit test harness that conforms to the XUnit standard. An ORM. We have more experience with a data mapper ORM. It's generally more fun, but I'd like to see somebody adapt this for Active Record. That'd be interesting, I think. And then we're going to bootstrap an in-memory database to the ORM inside of our test harness. By doing that, we're going to be able to do fast, efficient data operations. And then with all these things on the backdrop, we're going to start building our unit tests on top of this setup. All right, so like I mentioned, with PHP, we can do it with PHP unit. The Doctrine ORM works really well, and SQLite. In Java, I've done it with JUnit, Hibernate, and HSQLDB. The workflow I'm going to show, I've literally done the exact same thing in Java. The Hibernate ORM in Java has the exact same entity manager interface as the Doctrine ORM, because Doctrine was built as a port of Hibernate a long time ago, and it has continued to grow alongside it. Which means if you can do this, in PHP with Doctrine, you can do it just fine in Java. You can also do it in .NET. Not a big deal, because .NET has NUnit, it's got NHibernate, it's got SQLC. So all the same thing. In the end, it's just OOP. So with this said, before you dive into this, you want to commit to test-driven development. And you want to try to enforce that you are actually doing test-driven development with tooling to do a code coverage, to run a code coverage. And if this code coverage is anything but 100%, track it down and fix it. Okay, it's really easy to start at 100% and kind of stay there if you're doing test-driven development. Don't let your coverage slip below 100%. There is no point. If you're doing test-driven development, your coverage is going to start at 100% and it's going to stay at 100% as long as you're doing TDD.
I'm sorry.
I've
always got code that is like, well, if the database fails here, I'm going to have an exception which I will catch and log something here. And testing, then it logs something there. That one line of code, the log.error database just crashed
that, and there's like so many ways
I mean, I agree, like.
that you can, it comes down to architectural layers, and you have third-party components. Those third-party components are not your code. If you use basic,
I still have to catch the exception that they throw, and I have to log something. And that is something that is probably never gonna happen.
But you can totally throw exceptions from your test runs.
Well,
yes, you can.
Well, so
when you throw an exception in Java, you have to catch it, you can use it, otherwise your application terminates. In PHP, you catch the exception at the top level, your request fails, and it's the end. You have one or two places that there's a log and a catch.
let me just put it this way.
Particular scenario.
I've got 20 service classes, 50 command classes, 20 repository classes, covered by over 2,500 tests, 8,000 assertions that would disagree with you, and it's 100% code coverage. It is doable. Again, it comes down to your command of, OOP, design patterns, how you can decouple your system, having a proper architecture.
we have 2 enterprise applications that are 100% covered.
Yeah, yeah. So it's completely doable. So in the end, like I said, you don't want to have less than 100% coverage. So one thing I want to touch on is that even if your tooling says that you have 100% code coverage, you could still have meaningless assertions. Because what will happen is sometimes somebody wrote some code that was not there to satisfy a test, and maybe they wrote some test after the fact, and you might have 100% coverage because that code got run, but the assertion that you have against it is meaningless.
That's how you get to 100%.
Right. Right. That's how you cheat. But again, know what you're getting into. In the end, this is why peer code reviews are very important, because you don't want to have code that's 100% covered with meaningless assertions. And so this is one of the most impactful things that a code reviewer can do. Is kind of look at unit tests and make sure that the assertions are sufficient. So let's look at a little bit what a TDD workflow might look like. One of the first things you want to do is to, like I mentioned earlier, decouple your business logic from the framework stack. If you have to deal too much with your framework, test-driven development is going to be a little bit painful. So if you look back at this architecture that we talked about earlier, and you pit it against what a couple workflow might look like. So let's say you have, so this would be the example of what's kind of more challenging than you want it to be, right? You have your business logic, above it you have your controller, above it you have your routes, and you may have your UI on top of it, and then downstream of it you may have SQL migrations that you need to run to update your local schema. And you can certainly do kind of TDD against this entire stack all at once. It's just with these intertwined concerns, it's a little bit less productive. It's doable, a lot of people do it, and it's fine, it's better than nothing, but it's a little bit less productive than what I'm going to advocate. So if you take this business logic here, under the right architecture, which I just covered earlier, and you kind of put it up there on its own, your business logic is going to be made up of entities, repositories, and services. So the entities are going to be the things of the universe, right? A user entity, an event entity, a ride entity, a location entity, right? And these entities are interrelated into some kind of a entity graph, right? A user can have multiple roles, for example. A role could also be an entity, right? And then you have your repositories and your services. So if you can do test-driven development inside of this, then you can work in really rapid iterations while doing test-driven development, because you are not being anchored down by your controllers, your route, kind of middleware concerns, and you're not being anchored down by, what the state of your local MySQL database may be like. You're able to work within the comfort of your OOP code that you're building in a test-driven way. So once you've built a bunch of business logic in rapid iterations right here, what you're going to do then, once you're satisfied with a body of use cases, then you can leverage your ORM to forward engineer your database schema. And this is kind of to automatically generate your database schema. And this is kind of one of the most impactful things that you can do with yourself, is to stop thinking at your database layer and to just think of entities and relations to one another and how they interact through your code. And then you can use your ORM to automatically generate the schema that will reflect what your entity graph is like. So your entities are interrelated to one another, and with the ORM, it's going to generate the correct migrations with all of the foreign keys in place. So once you've done that, then you're about ready to start manual testing, right? So again, the goal of the workflow is you spend a bunch of your time here in rapid iterations, and only when you're satisfied that you've done enough that you want to start, sanity check your work in a manual way, then you just kind of run this and then hook up your routes, and then you can start testing in your web browser. But the goal here is to spend a lot less time testing, like a fraction of the time testing in your web browser. So from a workflow standpoint, another way to look at this workflow would be you start out by doing test-driven development against one or more repositories. Then you'll do test-driven development on one or more services to use those repositories. And you can repeat that a bunch of times while somebody is working on the UI concurrently. That's not a big deal. And you just kind of keep doing that, right? And then again, once you're done with enough of your use cases and you're satisfied, then okay, just map some URI routes to your service methods, generate your SQL migration, from your ORM automatically, run those migrations, and then test the application through the UI. But again, the goal here is, if you look at these two things in two separate zones, these two zones are decoupled, right? You can keep working on this without having to worry about that too much. So I have a kata online. It's in my GitHub repository, and I have a recorded video. I'm going to give you guys a link to that. But this is just kind of a fictitious ride-hailing application, where you could have a concept of users, locations, roles, rides, ride events. So if you have a ride that has a passenger, a driver, a departure, and a destination, a ride might go through different ride event cycles. A ride event could start requested and go through all these event cycles, right? This is a sample of something that you could build, and so I kind of did that in a test-driven way. So here I have an example of doing this in Symfony with Doctrine. The reason I picked Symfony is because it's really easy to bootstrap this. This is my base test class. That makes it easy. The only thing that matters here is the fact that this will recreate the schema at every test based on all of the entities that are available in your entity graph. So the first thing I do here is, it's going to be hard to see, but test, create, and save user. I create a new app user, it doesn't exist. Then I save it to my repository, and I assert that the user's ID is greater than 0, in which case it means that the ORM did its job. So then I write a bunch of code to make it pass, and now I'm green. So I was red, my test failed, now I'm green. So I have this whole recorded kata. These are screenshots from the recorded videos. I'm not going to spend too much time on it because it can be a little bit painful. But just to show you the various steps, first thing is test, create, and save user. Then I said test, get user by ID. Then I make it pass. Then I say test, assign the driver role to a user. Then I make it pass. Test passenger role to the user, make it pass. Here I verify that a user can have both roles. That did not result in me creating more code. I just wanted to make sure that whatever I had kind of satisfied this condition. And then here I made a test to make sure that if I try to do a duplicate role assignment, then it throws an exception. So I got that working in the repository. Then I did a service to use the repository. So here I'm creating the service by passing in my repository to which I pass the entity manager. So now I have a working service which uses my repository inside of my test harness. And I get these use cases surfaced through the service. And so my service API is a little more human friendly, right? I straight up have I have a new user, yeah. I have a new user method on the service. Here I have a make user driver to which I pass the user. So then I make it pass. Test make user passenger. Yeah, and that's it, really. All right. So here's the finished service. So this is the service test, and this is the implementation. And here's the repository. So this is the finished repository, not the test. Then here's a user entity. So you have the user properties, and these are the ORM mappings to make the entity work inside of the ORM. And these are the different methods that are on the user. And here's my role entity. This one's pretty simple. So yeah, like I said, the next step now is you can generate your migrations SQL file by using the doctrine diff command. When you run doctrine diff, it's going to look at your entity graph, and it's going to compare that entity graph with the current state of your local MySQL connection, and it's going to generate the migration to bring your local database up to date with your entity graph. And again, this is great because you can keep changing your mind as you can add more properties, you can switch things around, you can rename things, all this in code, and you can let Doctrine do the tedious work of generating the entire database schema for you. And it'll create it as part of migrations up and down. It creates them automatically for you. All right, so I have the code. So I have the recorded video. It's 45 minutes to kind of go through this tutorial. Kearney has seen it, right? Soon. All right. And then I have the source code on this branch right here. So you can click on it and you can see that, the code. So if you want to read more about TDD and some challenges that people run into and how to overcome them, a couple more articles here. I recommend Martin Fowler's Refactoring book, and also recommend Michael Feather's Legacy Code book. Because what I just described is how to deal with something greenfield, right? Obviously, we rarely ever get to do that, and we always inherit some messy code. So if you want to work with this, these books are very impactful and kind of helping you do that. So anyway, to get back to the benefits of doing TDD in web applications is you can keep your UI workflows decoupled from solving business problems. It's easy to get in the zone and to stay in it. When you work in a test harness, kind of back and forth, you'd be amazed at how productive you can be once you kind of get used to it. And even if your boss comes to you and is like, "Hey, how's it going? How was your weekend?" And you had all these variables in your head and everything blows up. TDD makes it really easy for you to get back into the zone because you can just look at the last test that you wrote, and that's kind of your anchor. It tells you exactly where you were at. And also with TDD, you don't have to worry about, again, like I mentioned earlier, that optimal design, right? You can kind of iterate your way into it. Implement first, optimize later. Just kind of get things working. So another big advantage, obviously, is, like I said, you get 100% code coverage for free. If you are doing test-driven development and you're truly adhering to it, then you have 100% test coverage without any extra effort. And it gives you sustained velocity, which is really what I would measure true agility. To me, agility is not, hey, I follow the Scrum process. Agility is, I'm always able to release new features at a predictable pace. I can bring business value into this world at a predictable pace. This is what a true agility is. In the end, unit tests are the living documentation of your application. You know, the written documentation, by definition, gets outdated the second you write it, right? But unit tests, you can just read the unit test. They read just like English, and it tells you exactly what your application is supposed to do and how it's supposed to do it. So I recommend doing TDD, obviously. Do it when prototyping. You know, if you know, a startup founder, you know, PHP CEO has a gun against your head, and it's like, hey, you know, build me this feature the fastest way you can. I would argue that doing TDD with this methodology is the fastest way you could do it. You can ship faster with TDD, and you can also embrace constant change, because if you build a prototype, you know, people will tell you, oh, this is great, let's go with this. Okay, well, you'll be glad that you've done TDD if you have now you have a robust system to keep building things, basically. So yes, do it. Do it when building complex things. Do it when building simpler things. In the end, test-driven development, the idea here is to not pit better against faster, is to really have better fuel faster. Because in the end, better software fuels agility. Better software means more fun. And it also keeps you in business. That's a nice side effect, right? I mean, a big part of my having fun is just, you know, still getting paid. So I'm a big fan of that. So in the end, you want to be doing a whole lot less. Has anybody ever seen Shawshank Redemption? Anyone? Okay, all right. You want to do a whole lot less of crawling through a river of crap, right? I'm sure you felt this when trying to decipher some code out there. And you want to do a whole lot more of writing better software by leveraging test-driven development, clean code, and design patterns, such that your better software can truly be at the center of an effectively working agile stack. And you can make the most of your Scrum processes, you can make the most of your continuous integration system, and you can make the most out of your MVC framework. Because if you do all that, then you're putting yourself in a position to release new features at a constant pace over time, which means your business value keeps skyrocketing. Then you can go public and retire. So you can come out clean on the other end. So this is me. I also happen to be hiring. I have 2 positions to fill on my team. This is the link. All right.